Hi, I'm here to present my project and prototype. Currently, about my project. Um, this is on the VS Code, and I do have a repository as well, and you can always refer to that as well. The link is um, attached to the status report file, and I have a source folder that my main files are going to be in the model itself, which basically will train and evaluate the model. It usually gives a 97% accuracy, saying that it's very ideal in a AI AI theory, and I will evaluate it with the noise, evaluate with the latency, um, and the staleness, noise and latency together, another different type of function, and a combination of a noise and latency and a staleness, as you will see over here. And to also evaluate the control safety margin, and yeah, and this is for the model. And then for the run experiment Python file, it's basically made also functions for the reporting, um, as you will see in different functions, and then latency report. Yeah, this is basically gives me all the results from the gives me all the results and attach and append them to the CSV files, and then later on I have this plot results Python makes plots from the information I get, and have some like a test files, as you can see over here. But the most important part is the result that I'm getting. And as you were seeing my terminal, what happens is I usually just run the plot result. It makes the plots and it saves the plots to as a PNG file, which just an image. But the important thing is when I run the model, it gives a result and everything. And as you can see, let me source of the experiment. Once I run it, it just generates the whole, and it saves the week 5 safety margin to CSV. And these are the results I'm getting. These are for week 2 and week 4. This is like accuracy, sensitive noise. And of course, the project is to show that traditional AI modeling and machine learning looks perfect, but in the physical world, does not have the same result. And my whole point of the project is to show that, and try to make some test cases to be able to show that actually in the physical world, the traditional AI and machine learning fails a lot, unlike the expectation. This is for like a plot for the week 4 stainless dynamics, slow and fast world. So basically, it shows like the how stainless effective. As you see, the accuracy drops if the delay goes higher, and as you see that in the slow world, accuracy doesn't drop as fast as the fast world. These are all like CSV files, of course, for the numbers. And this is another interesting part. This is for AI failure boundary versus latency. So when the latency happens, effective accuracy drops. So basically, what it says is depend on how much is the delay exists, depend on like a model in the physical world. There's a deadline, and if we don't follow the deadline, that would actually make a big mistake. So we need to know how much of a deadline we have in every single model. If it's more than a deadline, that's gonna be fail. It could be like a driving a Tesla or Waymo cars. That's a huge liability for the company, because that would be into a crash, right? And And as you can see over here in this plot, this is safety rate, basically no latency penalties for the blue, and it looks pretty ideal. No problem with that. It doesn't say the model has an issue. The only issue is it's not effective because there's no timeout, there's no timing in it. But this one, it shows once the timeout passes, which probably is close by here, the accuracy drops, like the safety, and just drops significantly. And of course, this is very similar. I think I just showed this earlier a little bit, and these are the CSV files. The project is so far basically showing all these things, and for the next week, I'm thinking about working on more test cases and have like more explanation on my readme.md file. I've done some explanation. I'm thinking about add more explanation to represent the case, like maybe in a slideshow a little bit better as well. But so far the project is looks pretty good. I'm pretty glad it turned out to what I was being expected. Um, so I'm gonna be trying to develop it more and take it from there to see what are the other extensions that I want to follow. Thank you so much for following and following the project and watching the video.